Hi gang, happy Friday. So on your upcoming test 1, you're going to have this problem on the test. Of course, the numbers will be slightly different, but it will be something like this. This is what it'll look like on Alex. Let's go over it, okay? You're graphing a piecewise function, and you're going to say if it's continuous or not. All right. So the first thing you want to do is draw these individual functions. So there's two functions here. So these are you're going to get two linear cases. These are both linear. So you have the first one here and the second one here. Those are the two functions. Since these both have an x and a y intercept, I solve for that. So if x is 0, y is 3. If y is 0, x is 3/5. I wrote it down here. If y is 0, you could solve out that x is 3/5. So I first put up the 0, 3, and the 3/5, 0. And I drew an initial line, okay? I drew an initial line to represent this graph. Then I did the same thing over here for this graph. For y equals x minus 4, I found the intercept. So when x is 0, when I plugged in x is 0, y came out as -4. When I plugged in y is 0, x came out as 4. And then I drew this line here, okay? I drew this line here. Now, those were the lines. You then have to go back and look at the domain restrictions, because this graph, this final graph, this piecewise function is being cut and pasted together. It's like a collage of these two graphs are making this. So you're cutting and pasting two functions together to make a new function. That's what you're doing. It's an interesting concept. So over here on the right, these are the domain restrictions. This is where you're basically turning on the function, and that's basically the part of the function that you're going to use in the final edit. So for the first function, you're going to only use x values less than or equal to 2. So because it has a bar, it means you're actually going to include the 2. So you have to take that 2 value and plug it into the x value. So you see here I plugged it in, and I got that y was -7. So if I put in 2, I get out that y is -7. And again, notice I wrote closed because this has the bar. So I graphed to -7 down here. This is what we would call a boundary value. Okay, and that is where we're basically taking the line and we're cutting it right there. We're cutting it into two pieces. And you want to take the correct piece to your final answer. So x values less than or equal to 2 go that way, right? Think of things that are less than 2. Things like 1, 0, -1, -5. So that's why you're noticing I'm taking this side of the graph over here, the left side of the graph. And I'm not going to take the right side of the graph. So that part in pink, this part right here, you'll notice that I transferred it to the next page. I transferred it to the next page, sorry. Okay, so that's this part here, from the 2, -7 here. That's me transferring the first function. Okay, so now if we come back, this second one is cut at x greater than 2. Now, even though it doesn't equal to 2, you still want to plug the 2 into the function. So you want to say 2 minus 4. So if I do 2 minus 4, that means the y value is -2. So at 2, the y value is -2. And it's open because, again, notice that this one doesn't include 2, but this one does. So since it doesn't include 2, that means that it's open at 2, -2. Now, you want everything to the right of 2. Things to the right of 2 are things like 3, 4, 5, things over here. So if you think if I cut this in two pieces, you want the right side, because the right side is where the x values are bigger than 2, right? Things like 2, 3, 4, and so on. So this pink part from the 2, -2, that's the part that I transferred over to here, that I transferred over to the right. Now, this is the final graph of the f of x. This is the final answer, this graph here. And you're going to have to use the tools here to graph it. But you'll also notice at the bottom it says determine whether or not the function is continuous. What it means to be continuous is that whatever you're drawing, you don't have to pick your pencil off the paper. So that means it has no holes, no gaps, no like vertical asymptotes. It would basically be a roller coaster ride that you would be okay having for the most part. Now here, if I asked you, would you like to take this roller coaster ride? You'd say no, because you'd fall out right here, right? The tracks don't connect. So this would be considered not continuous because the two graphs do not connect. Now, by the way, if you have an open on top of a closed, if you have an open on top of a closed, what they do is make a closed. It like snaps together like a button, like a snap. So if you have an open on top of a closed, that's considered continuous, and then that roller coaster would be good to ride. We didn't have it in this case. Okay, gang, if you have any questions, please email me, and I'll leave it at that. So this, again, this question will be on your exam, graph a piecewise function. And so I would graph it, and for this case, I would say no, for it's not continuous. All right, catch you in another video. Bye-bye.